and 8th graders. We're here with lesson 5-8 on ratios and probability. So here you have two vocab words. An outcome is any of the possible results that can occur. And an event is a collection of outcomes in an experiment. And this is actually a collection of all the possible outcomes in an experiment. So here we have the probability of an event equals the number of favorable outcomes, so what they're asking for, divided by the total number of possible outcomes. Okay, so let's look at example number or letter A. You choose a ball at random, and we have all of these balls right here that are all different colors. So what is the probability that we would find a blue one? So find the probability of blue. So we're going to start by counting up the favorable outcomes. It's favorable if we pull a blue one. So let's count all the blue balls. We have 1, 2, 3, 4. And we're going to put that over the total number of possible outcomes, which would be any different ball that we would pull. So how many balls are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 4 over 12. And we know that that can be divided. And so we're going to divide both by 4. And we'll go 4 goes into 4 ones. 12 divided by 4 is 3. So the probability of pulling a blue ball would be 1/3. We can also show this as a percent, which would be 33.3% chance. All right, let's try this one. Find the probability of not getting a red one. So I want you to do this one on your own. You're going to count up all the choices that are not red and then put them over the total number of balls. Let's look at the next part. So you can express probability with fractions or percents. Anything that has a probability of 0 is impossible. Anything with a probability of 1 is certain. Same thing with percents. 0% impossible, 100% chance, certain. And then at half, we have half as a fraction, 50%. This is equally as likely. Let's write equal. This means that it's equally likely that it will or will not happen. So anything in this area between 1/2 and 1 or 50 and 100% is more likely. Anything in this area is less likely. All right, go to the second page. The collection of all possible outcomes, Scott Crawdoff, of all possible outcomes is called the sample space. You can find the sample space with a table. All right, and this is the way this works. This looks a little tedious, but it's not hard. It's just takes a long time. So example B, construct a sample space for rolling 2 number cubes. Again, the G got cut off. Rolling 2 number cubes. So what you're going to do with a sample space is along the top, you're going to write all the possible outcomes for one event. And along the bottom, or this side here, you're going to write all of the possible outcomes for the second event. So the first event is the first number cube that I rolled. So when I rolled that first number cube, I could get a 1, 2, 3, 4, 5, or 6. When I roll the second number cube, I could get a 1, 2, 3, 4, 5, or 6. And now in here, I'm going to fill in all of my possible choices, my possible outcomes. So if this one roll the 1 and this one roll the 1, then in here I would get 1, 1. If this one rolled the 1 and this one rolled the 2, I would get 1, 2. Here I would get 1, 3. Here I would get 1, 4, 1, 5, 1, 6, 2, 1. You get it. You're going to fill in the whole thing. All right, now that I have my sample space filled in, and you should do the same, I can answer these questions. So it says, find the probability of getting a product of 12. Remember, product is times. So I'm going to look through this, and I'm going to look for any ones that show me a product of 12. Let me get a different color. Mark them. So 1 times 1 is 1. That's not 12. I'm going to go through, and I know my factors of 12, right? So this is nice and easy. I can look for 2 times 6 is going to be a product of 12. 6 times 2. 4 times 3. 3 times 4, and that's it. So I have 4 different products of 12. So down here, I will write 4. That's my favorable outcomes. And I'll put it over the total, and I can find that through multiplication. There's 6 rows and 6 columns. So 6 times 6 is 36. And then I'm going to simplify that to 1/9. 4 goes into both of those. And now I can write that as either a fraction or as a percent. And I'll find it as a percent by dividing 1 by 9. And then I will move it over 2 places, and I get that that is 11.1%. All right, next one. Find the probability that the sum is odd. Okay, so let's look back here. And I want you guys to try and do this one on your own. So you're going to add them up and figure out whether or not they're odd or even. Circle them with a different color if they are odd, and then put it into a fraction or a percent. And you might figure out a pattern that speeds this up a little, and that's okay. All right, now that's the end of those, but I did want to show you the last type of question from your book. All right, this is called a tree diagram. A family has 3 children. Find the sample space showing the number of boys and girls in the family. Then find the probability that there are at least 2 girls, given that the probability of boys equals the probability of girls, so they're the same. Express the probability as a fraction. So here we go. The way that they did this, they have child number 1. What are the possible outcomes of child number 1? It could be a boy or it could be a girl. Then you go to child number 2. For this outcome, this child could be a boy or a girl, and then you're going to repeat that down here, a boy or a girl, because this says the first time they got a boy, then their second child could be a boy or a girl. Or here, if their first time they got a girl, their second child could be a boy or a girl. And then you repeat that for child 3. You could have a boy and a girl, a boy and a girl, a boy and a girl, a boy and a girl. And then you write them across into the sample space. So you could have gotten a boy, and a boy. 3 boys. You could have gotten a boy, and a girl. Boy, boy, girl. You could have gotten a boy, a girl, and a boy. Or a boy, a girl, and a girl. And they just wrote them all down. And this is our given sample space. This is another thing that is very annoying to do. But when you have 3 different events, you can't do them in a chart or a table. So this would be the way that you could do them, using a tree. And then after you have your sample space, that's where you would get your questions from. So the probability of at least 2 girls, I'm going to look up here and find all the cases where there's 2 girls. That one's 2 girls, this one has 2 girls, that one has 2 girls. This is 3 girls, which is at least 2 girls. So we'll add up all those, and we get 4, and then there's a total of 8 in our sample space, so 4 over 8 equals 1/2. All right, guys, well, we went through a lot. Try those problems that you have to fill in, and I look forward to seeing you in class. Go ahead and get to work.